Okay, welcome back.
So here next point is that failure of wave theory to explain the observations from experiments on photoelectric effect. So what are the failures of wave theory to explain the observations from experiments on photoelectric effect? So most of these observations could not be explained by wave theory of electromagnetic radiation. So here we totally 9 observations already seen in this topic. So here these 9 observations or the observations are not could not explain on wave theory of electromagnetic radiations. First and foremost was instantaneous emission of electrons on incidence of light. There is a wave picture we would expect that the metal surface will absorb the incident energy continuously. So all the electrons near the surface will absorb energy. The metal surface will require reasonable time to accumulate sufficient energy to knock off electrons. So greater the intensity of incident radiation, more will be the incident energy. Hence expected time required to knock off the electrons will be less. For small incident intensity, energy incident on unit area in unit time will be small. So here let us try to estimate the time that will be required for photocurrent to start. We need to define the term work function of a metal for this exercise. We know that metals have free electrons. This fact makes metals good conductors of heat and electricity. These electrons are free to move inside the metal but are otherwise confined inside the metal. So they cannot escape from the surface unless sufficient energy is supplied to them. So minimum amount of energy required to be provided to an electron to pull it out of the metal from the surface is called work function of the metal and is denoted by phi naught. So the minimum amount of energy required 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 आता minimum amount of energy कशाला पाहिजे to be provided to an electron to be provided to an electron so minimum amount of energy required to be provided to an electron to pull it out म्हणजे त्याला जस्ट बाहेर खेचण्यासाठी कशामधून मेटल सरफेस मधून to pull it out from the metal surface from the pull it out of the metal pull it out of the metal from the surface is called the work function of the metal is called the work function of the metal and which is denoted by phi naught and the question denoted करायचा आहे phi naught. So work function depends on the properties of metal and nature of its surface. The values of work function of metals are generally expressed in unit of energy called electron volt. So हे जे आहे ते आपण कशामध्ये एक्सप्रेस करतो इलेक्ट्रॉन व्होल्ट. So here some work functions are given in chart. हे बघा काही वर्क फंक्शन्स आपल्याला इथं चार्ट मध्ये दिलेले आहेत. टिपिकल व्हॅल्यूज ऑफ वर्क फंक्शन फॉर सम कॉमन मेटल्स. तर पोटॅशियम असेल तर बघा 2.3 इलेक्ट्रॉन व्होल्ट एवढी एनर्जी लागते. एखादा इलेक्ट्रॉन बाहेर काढण्यासाठी. सोडियम असेल तर 2.4, कॅल्शियमसाठी 2.9 आहे, झिंकसाठी 3.6 आहे, सिल्वरसाठी 4.3, ॲल्युमिनियम सेम, टंगस्टन 4.5, कॉपर, निकेल आणि गोल्ड हे आपल्याला दिलेले आहे. सो हिअर नेक्स्ट आपल्याला तर इथं बघायचं आहे एक्झाम्पल 14.1. सो नेक्स्ट एक्झाम्पल. आता मी हे एक्झाम्पल ब्लॅकबोर्डवरती लिहित नाही, तर तुम्ही जनरली हे एक्झाम्पल लिहून घ्यायचं आहे. एक्झाम्पल 14.1 लिहून घ्यायचं आहे. सो रेडिएशन ऑफ इंटेन्सिटी 0.5 इंटू 10⁻⁴ वेबर पर intensity watt per meter square falls on the emitter in a photoelectric setup. The emitter cathode is made up of potassium and has an area of 5 cm square. So here let us assume that the electron from only the surface are knocked off by the radiation. So according to wave theory, what will be the time required to notice some deflection in the micrometer? Micrometer connected in the circuit. Give the metallic radius of potassium is 230 pm and work function potassium 2.3 electron volt. So here intensity of radiation किती आहे बघा 0.5 into 10⁻⁴. Area of cathode 5 cm square. Radius of potassium atom 230 picometer. Work function of potassium 2.3 electron volt. Okay. सो पिकोमीटर मीन्स 10⁻⁻12 आपण त्याला हे करणार आहे. इंटेन्सिटी ऑफ रेडिएशन किती दिले 0.5 इंटू 10⁻⁴ दिलेलं आहे. एरिया दिला आहे 5 इंटू 10⁻⁴. रेडियस दिलेलं आहे 230 पिकोमीटर म्हणजे 10 टू 10⁻12. आता वर्क फंक्शन म्हणजेच काय 1.6 इंटू 10⁻19 जूल. सो हिअर द नंबर ऑफ एन इलेक्ट्रॉन्स present on the surface of cathode can be approximately calculated using the each potassium atom. So contributes 1 electron in radius of potassium atom is 230 into 10⁻12 meter. So n is the area of cathode upon area covered by one atom. So area of cathode 5 into 10⁻⁴ upon area covered by one atom, that is 3.1415 into 230 into 10⁻12, again 230 into 10⁻12, that is 3009 into 10⁻12. Incident power on the cathode is दिलेले आहे. ओके, तर तुम्ही हे एक्झाम्पल काय करा होमवर्कसाठी घ्या. एक्झाम्पल पहिलं, जर अडचण असेल तर मला डाऊट विचारा. ओके, नेक्स्ट पॉईंट आपण इथं बघणार आहोत. Next, Einstein's postulate.
चाललंय बघा आज इकडे आहे म्हणा. आमचं बाळाचं काहीच मागितलं
लाडू. The Einstein's postulate of quantization of energy and the photoelectric equation. So here Einstein's postulate of quantization of energy and photoelectric equation. So Planck's hypothesis of energy quantization to explain the black body radiation was extended by Einstein in 1905 to all types of electromagnetic radiations. So here Planck's hypothesis of energy quantization to explain the black body radiation was extended by Einstein in 1905 to all types of electromagnetic radiations. So Einstein proposed that under certain conditions, light behaves as if it was a particle and its energy is released or absorbed in bundles of quanta. He named the quantum of energy of light as photon with energy E is equal to h nu. So Planck's hypothesis of energy quantization. Here Planck's hypothesis of energy quantization to explain the black body radiation was extended by Einstein in 1905 to all types of electromagnetic radiations. So Einstein proposed that under certain conditions, light behaves as if it was a particle and its energy is released or absorbed in bundles of quanta. So he named the quantum of energy of light as photon with energy E is equal to h nu. So where nu is the frequency of light. Where nu is the frequency of light and h is a constant defined as Planck's in his model to explain black body radiations. So it is now known as Planck's constant and has a value. So here Planck's constant value ji ahe. Nu is the frequency of light and h is a constant defined by Planck in his model to explain black body radiations. See, it was known as Planck's constant and has a value h is equal to 6.26 6.626 10 raised to minus 34 joule second. So if त्याची काय असेल व्हॅल्यू आहे h ची. So it may be noted that the equation E is equal to h nu. आता आपला आइन्स्टाईनचं प्लँक्स कॉन्स्टंटचं इक्वेशन काय आहे दिसते का सगळ्यांनी? ओके, ते आहे बघा एनर्जी E is equal to h nu आहे. So it is a relation between a particle like property energy and wave part like property frequency. So this is known as Einstein's relation. Let's आपण काय म्हणतो Einstein's relation. So Einstein's relation holds good for the entire electromagnetic spectrum. So it says that energy of electromagnetic radiation is directly proportional to the frequency and inversely proportional to the wavelength. So nu is equal to c upon lambda. So Einstein's relation holds good for entire electromagnetic spectrum. It says that energy of electromagnetic radiation is directly proportional to the frequency and is inversely proportional to the wavelength. So nu is equal to c upon lambda. Hence high frequency radiation means high energy radiation. So short wavelength radiation means high energy radiation. Okay. So this is Einstein's postulate of quantum energy. That is E is equal to h nu. ओके, तर कॅमेराच्या ते मध्ये मी आलो तर ते थोडंसं ब्लर होतंय. ठीक आहे. आता ह्याच्यामध्ये काय आहे पॉईंट्स आहेत ते आपल्याला इथं बघायचं आहे. सो एक्सप्लेनेशन युझिंग आइन्स्टाईन्स पॉस्टुलेट ऑफ क्वांटायझेशन ऑफ एनर्जी फॉर द ऑब्झर्वेशन्स मेन्शन्ड इन सेक्शन बिलो. दॅट इज फर्स्ट पॉईंट काय आहे बघा. Here, Einstein argued that when a photon of ultraviolet radiation arrives at the metal surface and collides, then what happens with an electron? It gives all of its energy H. So, काय म्हटलं बघा फर्स्ट पॉईंट आपण. Einstein argued that argued that Einstein argued that when a photon Einstein argued that when a photon of ultraviolet radiation arrives at the metal surface arrives at the metal surface and collides with an electron collides with an electron it gives all of its energy h nu to the electron. So it gives all of its energy h nu to the electron. So the energy is gained by the electron and photon no longer exists. So if phi naught is the work function, समजा याच्यामध्ये काय असेल, if phi naught is the work function, समजा phi naught हे जर त्या ठिकाणचं काय असेल, एक वर्क फंक्शन असेल ऑफ द मटेरियल ऑफ द इमिटर प्लेट, म्हणजे त्या इमिटर प्लेटचं असणारं वर्क फंक्शन काय असेल, phi naught इतकं असेल. Then electrons will be emitted if and only if energy is gained by the electrons is more than the work function. That is here h nu is greater than or equal to phi. There's a minimum or threshold frequency. The minimum or threshold frequency काय असेल, mu naught असणार. So threshold frequency mu naught is required to eject the electrons from metal surface. Of course, so frequency is greater than threshold frequency असेल, then photon will not have enough energy to liberate an electron. So as a result, no electron will be ejected. Clear दिसते का सगळ्यांना? Okay. So as a result, no electron will be ejected, however intense the incident radiation is. Similarly, if nu is greater than nu naught, the free energy will always be sufficient to eject an electron. Okay. So this is the first postulate, is that Einstein argued that when a photon of ultraviolet radiation arrives at the metal surface and collides with an electron, it gives all of its energy h nu of the electron. So this energy is gained by the electron and photon no longer exists. If phi naught is the work function of that material of the emitter plate, then electrons will be emitted if and only if energy gained by the electrons is more than or equal to work function. Thus minimum or threshold frequency nu naught, मग या ठिकाणी मिनिमम किंवा थ्रेशोल्ड फ्रिक्वेन्सी काय असेल, nu naught is equal to phi naught upon h, is required to eject the electrons from the metal surface. If nu पेक्षा जर समजा nu naught is greater असेल, the photon will not have enough energy to liberate an electron. So as a result, no electron will be ejected, however intense the incident radiation is. Similarly, if nu is greater than nu naught, the energy will always be sufficient to eject an electron. Okay. However small the incident intensity is. So this is first postulate. What is the first postulate? Here Einstein argued that when a photon of ultraviolet radiation arrives at the metal surface and collides with an electron, so it gives all of its energy h nu to the electron. So phi naught is the work function. So such that h nu is greater than or equal to phi naught. That is work function जर इतका असेल. Then what happened here? If nu less than crystal frequency, then electrons does not exist for a longer time, or electrons are not emitted by the metal surface. But whenever this frequency is greater than nu, समजा ही जर threshold frequency त्या frequency पेक्षा जर greater असेल, then what happen? Then here the electrons are ejected by that metal surface. Okay. त्यावेळी मात्र इलेक्ट्रॉन्स काय केले जाते त्या मेटल सरफेस द्वारे इजेक्ट केले जातात. कधी इफ द म्यू नॉट इज ग्रेटर दॅन म्यू असेल तर. ओके. या ठिकाणी काय अडचण आहे का? सो दिस इज फर्स्ट पोस्टुलेट. आता याच्यामध्ये असणारा हा जो फंडामेंटल थ्रेशोल्ड फ्रिक्वेन्सी आहे, दिस इज इक्वल टू phi naught upon h. So threshold frequency is equal to phi naught, that is work function upon h. H means Planck's constant. h ची व्हॅल्यू किती असते? 6.626 into 10 raised to minus 34 joule second. So whenever the threshold frequency, that is phi naught upon h, is greater than its frequency, then and only then the electrons are ejected from that metal surface. Whenever the incident radiations are incident, here energy is that E is equal to h nu. So all these are photon energy. So whenever these energy are incident on any electron, then here what happens? This electron absorbs all photon energy. जेव्हा तो photon energy E is equal to h nu इतकं, हे बघा मेटल सरफेस मधून कंटिन्युअस इलेक्ट्रॉन्स बाहेर पडणं चालू आहे रेडिएशन्स होत असल्यामुळे. पण काही रेडिएशन्स मेटल सरफेस वरती पडत असताना त्याच्यामध्ये काही फोटॉन्स जे आहेत ते त्या इलेक्ट्रॉन वरती पण इन्सिडेंट होणार आहेत. तेव्हा त्याच्यामध्ये काही इलेक्ट्रॉन्स वरती जेव्हा ते इन्सिडेंट रेडिएशन्स पडले मेटल सरफेस मधून इलेक्ट्रॉन्स इजेक्ट होणार आहेत 100% नो डाऊट. आता जेव्हा इलेक्ट्रॉन्स बाहेर पडत असणार आहेत तेव्हा काही इलेक्ट्रॉन्स वरती ती फोटॉन एनर्जी इन्सिडेंट होईल आणि ती असणारी फोटॉन एनर्जी जेव्हा त्या इलेक्ट्रॉन वरती इन्सिडेंट होणार आहे तेव्हा ती इलेक्ट्रॉन ते सगळं असणारी एनर्जी ऍब्सॉर्ब करतील आणि ऍब्सॉर्ब केल्यामुळं दे डज नॉट एक्झिस्ट फॉर अ लॉंगर टाइम. तो इलेक्ट्रॉन जास्त काळ तिथं टिकत नाही. ओके. सो दिस इज फर्स्ट हियर point. Next, second point is that energy is given by the photon to the electron as soon as the radiation is incident on the surface. बघा, energy is given by the photon to the electron as soon as the radiation is incident on the surface. The exchange of energy between the photon and electron is instantaneous. जी काय exchange होणार आहे एनर्जीचं ते कसं आहे instantaneous. Hence there is no time lag between the incidence of light and emission of electrons. So also when the incident radiation is stopped, there are no photons to transfer the energy to electrons. Hence the photo emission stops immediately. तर बघा सेकंड पॉइंट काय आपला म्हटलेला आहे इथं. Here, second point. Energy is transferred to the electron by the photon as soon as the incident radiations are incident on them. Incident radiations त्या मेटल सरफेस वरती इन्सिडेंट झाल्याचं लगेच एनर्जी ट्रान्सफर करणार आहे फोटॉन त्या इलेक्ट्रॉनला. ओके. So energy is given by the photon to the electron as soon as the radiation is incident on that surface. But here the exchange of energy between photon and electron is instantaneous process. Exchange of energy between photon and electron is instantaneous. Exchange of energy between photon and electron the विषय है is instantaneous process. Instantaneous process. So this exchange is rapid process, instantaneous process. Okay. So hence there is no time lag between the incident of light and emission of electrons. So there is no time lag. No time lag. There is no time lag between incident of light and emission of electrons. Also, when the incident radiation is stopped, there are no photons to transfer the energy to electrons. Hence, the photo emission stops immediately. So, these are the 2 points here discussed already. Next, third point is that according to Einstein's proposition, if the intensity of incident radiation for a given wavelength is increased, there will be an increase in number of energy quanta incident on unit area in unit time. But the third point काय म्हटले बघा, according to Einstein's proposition, म्हणजे आइन्स्टाईनच्या propositionनुसार, if the intensity of incident radiation for a given wavelength is increased, तर according to Einstein's proposition काय आहे, if the intensity of incident radiation, समजा इन्सिडेंट झालेल्या रॅडिएशनची असणारी जी इंटेन्सिटी आहे फॉर अ गिवन वेवलेंथ म्हणजे दिलेल्या वेवलेंथसाठी इज इन्क्रीज्ड, देअर विल बी अन इन्क्रीज इन नंबर ऑफ एनर्जी क्वांटा इन्सिडेंट ऑन युनिट एरिया इन युनिट टाइम. करेक्ट आहे. So according to Einstein's proposition, if the intensity of incident radiation for a given wavelength is increased, there will be an increase in number of energy quanta on unit area in unit time. So energy of each quantum being the same. So larger intensity radiation will knock off more number of electrons from the surface and hence current will be larger. So conversely, lower intensity implies less number of incident photons. Okay. Hence less number of ejected electrons and therefore lower current. This is the third point. What is the third point? So according to Einstein's proposition, if the intensity of incident radiation, समजा incident radiation जे होत आहे त्या incident radiation ची जर समजा intensity कसं असेल for a given wavelength समजा जर increase झाली तर there will be an increase in number of energy quanta incident on unit area in unit time. So this energy of each quantum being the same, that is h nu is equal to hc upon lambda. So therefore larger intensity radiation will knock off the more number of electrons from the surface and hence current will be larger. Next here, fourth point. So next point, that is 4. Once the electron is emitted from the surface, okay, fourth point काय म्हटले बघा,